Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is going to be my Web Development Guide 2020. The idea behind this is just to kind of give you a good spattering of all sorts of different web technologies. We're not going to cover every single web technology in depth because there's just so many, but this is going to be a pretty exhaustive presentation that'll give you a really good exposure to what's out there and give you a very clear idea of sort of what order you should learn them in, because the presentation is kind of designed in the order like, okay, here you should probably learn this stuff in this order, up to a certain point. Then it's just sort of extra stuff. I'll kind of make that clear. Hey, I'm a web developer too, so if you ever need to hire a web developer, you can always contact me at hire@alexmerced.dev. You can check out my portfolio at alexmercedcoder.com. If you're an aspiring web developer, this should help you, give you a much clearer idea of your path. If you are someone who hires web developers, this should help you have a better conversation with your web developer. So please do enjoy. So essentially, again, we're going to be covering different types of web technologies and the different paths as far as different careers in web development. And not just web development, but QA, DevOps, mobile development. It goes on and on and on. So first, to really understand how all this fits in the picture, we need to understand, well, the web and what the web does and how it works. So everything really kind of keys in with the client browser. So every person who browses the internet has a browser, whether it's on their mobile phone or on their desktop. They might have something like Google Chrome, Mozilla Firefox, Microsoft Edge, Brave. You have some sort of software. And what that software can do primarily is makes requests. So when you type in google.com in your browser is actually sending out a request out into the internet. Now, your computer doesn't magically know where Google is to send the request. So across the internet, there's several computers referred to as domain name services. They're like a giant phone book working together to keep track of where all websites are located. So your request for google.com will first head over to google.com's DNS server, or a DNS server for Google's domain name, and says, oh, when you type in google.com, that request should be handled by this server. So the DNS gives you an IP address saying, here's where you should go. Then that request gets sent to that IP address, Google's web server, and the web server is really just going to be a computer running particular software, which could be done in any language. Okay, so that's why when it comes to the back end, you might have 10 different jobs in 10 different languages. It has software which receives the request and then sends a response. So everything from receiving the request to sending the response, this is what's referred to as the back end. So the front end is what the client browser does. The back end is the web server, everything between the request and the response, which could be pulling information from a database. So you might go to maybe your profile on Google. So you're saying, hey, I want to go take a look at my profile page. The web server says it gets the request. It's like, okay. Let me check to make sure that you're you, so authentication. Now, I don't want to have to be checking all the time, so let's kind of set some variables up so I know. So session, so that way I know you're logged in, and I have some other information I may need to continue servicing you. Now, you want to see your information from your profile, so let me go pull that information from the database. Okay, now how should the information look with your profile? Well, we're going to need to figure out what our template is and send that too. So we'll send you the HTML, CSS, JS, the template for how that information should look like, and we'll send you the information via JSON or XML, which are formats for sending information. So traditionally what would happen is that the server would render the page right up front. So in a sense, they'll just send you HTML, CSS, JavaScript with the data you asked for already packaged in. That's referred to as templating or server-side rendering. Nowadays what happens is you have what's called a single page application, where they send you one big HTML, CSS, JavaScript thing once, and that website will just ask the server for more data via JSON or XML as needed. Okay, so that way instead of making a lot of medium-sized requests, you make one initial big request from the server and then lots of little small ones afterwards. You can still do it either way, but just so you can understand sort of where what the back-end developer is designing, this part, the response, versus the client browser, which is when we get back that HTML, CSS, and JavaScript, how does the browser respond to it? Okay, so the person who's designing the HTML, CSS, and JavaScript that gets rendered by the browser, that's the front end piece. How the website's going to look like, and that typically uses HTML because while your web server can be designed any way you want, so it can use any language you want, because your user doesn't have to do what the backend does. Your Chrome browser doesn't have to do that stuff. But your client browser does have to do the rendering of the page. So every website does have to be created in the languages that a browser understands. And browsers understand 4 languages. For the most part, it used to be 3 until very recently. HTML, okay, which kind of is a structure of the website. So think of it as the noun. This is what the website is and the information it contains. The CSS, which is the adjective. How does the website look like? It describes the website. And JavaScript, which think of it as the verb. Like if I click on a button and it does something, that's going to be JavaScript. It's like your, or if stuff moves around, it's probably JavaScript. JavaScript kind of describes sort of the logic and action and more interactivity of the website. Now, more recently, they created what's called WebAssembly, or WASM for short. The idea behind WASM was, for the longest time, people were thinking, well, it would be nice if I could use something other than HTML, CSS, and JavaScript to render stuff in the browser. But everybody had their own favorite language. So it was hard to kind of sit there and say, well, what languages should our browser support? So the agreement between everybody was how about we create sort of a intermediary language, a sort of very low level, byte level language, meaning it's very fast. And what we'll do is that if I want to use Ruby on the front end, I would create a compiler that takes Ruby code and turns it to WebAssembly. People have already been doing this with things like JavaScript, where they compile the JavaScript, but it's not as fast as using WebAssembly. WebAssembly's super fast because it's what's called low level. We don't understand what that is yet, but it's fast, which makes it more useful for things like if you want to start doing like 3D gaming in the future in your browser. So imagine playing like sort of the top newest games in your browser. WebAssembly might make that possible. The front runners in making WASM compilers, because again, WASM is new, so it's not really fully implemented yet, in the sense that WASM exists, but we have to wait for people to make compilers to compile to WASM. And C# and Rust are probably the 2 languages that are furthest along in doing that. But in the future, probably all languages will have their WASM compiler. So this whole distinction between having any language in the back end and only HTML, CSS, and JavaScript in the front end will disappear over time, and you'll be able to kind of use anything on the front end. So that's sort of a picture of sort of the internet. So if you're going to be a developer, the first thing you really do need to learn is HTML, CSS, and JavaScript, and you need to get comfortable with it. I mean, really, really comfortable, especially HTML. CSS, you want to make sure you learn, like, get really comfortable with things like Flexbox and Grid. JavaScript, you want to get really used to like DOM manipulation, because you want to be able to move things around to create really interactive and cool looking websites. And you need to learn how to make AJAX requests. So this is primarily learning things like Axios and the Fetch API in JavaScript, so that way you can ask for information from different APIs and different sources to help feed your website. So generally, first things first, that's what you want to learn and get very comfortable with before you do anything else. Okay, so that's step number 1, master this stuff, which can take some time. Probably, if you're putting in three hours a day, a month should give you enough time to master this and feel really comfortable with it. Like probably 2 weeks for HTML, CSS, and again, I'm talking about 3 hours a day, and then JavaScript for another 2 weeks, which would include making AJAX requests. But I mean, you know, intense exercises and studying. Now, once you kind of got the basics, you got that foundation, you want to go deeper into CSS and styling, which means a couple different things. Mastering CSS animations. CSS has this whole functionality for animating a website and creating shapes and drawing that can take probably like a month in itself to really master, but it will allow you to create some really pretty and fast looking websites and really cool shapes. And especially if you're doing like browser games, this is really going to allow you to make some really cool stuff. Now, creating CSS can be very time intensive for a very large website. So something like a preprocessor like Sass, so the way the Sass works it allows you to create sort of a super CSS that has all these extra features like functions and mixins. So that way you're not typing the same stuff over and over again. It allows you to do all this stuff and then compile it to CSS. So you would just have to write your Sass code, and then it would automatically turn into CSS that the browser can read and save you a lot of time every time you want to make a change. Because if I use a variable for my colors, then every time I need to change a color in the website, I just change the variable. I don't have to change every style individually. So learning Sass can be very helpful. Then there's several CSS frameworks which are designed to help get a lot of the basics done. There's certain things you kind of always do with CSS as far as like styling buttons, styling forms, creating certain dimensions and grids. So things like Bootstrap, Materialize, Bulma, Foundation, Skeleton, Pure CSS, Milligram, and so many more, they kind of take a lot of that work out for you and give you a lot of built-in functionality. So that way you can focus more on just like the overall layout of your website instead of like, oh, how many pixels should the square have as padding and margins and things like that. I do recommend that you get really comfortable styling from scratch first. So that way, because oftentimes when you're using a framework like Bootstrap, Materialize, Bulma, they work really well and they save you a lot of time. But if you don't have a real comfort with CSS, you'll get frustrated when certain things don't work exactly the way you want. So you won't know how to add your own stylings on top of them to get things just perfect. But they serve as a really good starting place, especially if you're going to use a lot of its features. If you're really like just using one thing out of that whole framework, then maybe you're probably going to be better off with something like a Skeleton, which is just really bare bones, versus like using like a Bootstrap or Materialize, which has like a lot of stuff in there. That's really great if you make use of it, but if you're not going to, then you might want to go a different direction. Now JavaScript, once you learn the core of JavaScript and you learn DOM manipulation, there are a lot of libraries for JavaScript that'll help you add a lot of really cool stuff to your website and make it a lot easier to do really cool things like animations, like doing like full screen background videos. Like sometimes you'll see like their hero images for a website. Instead of it being like a static image, it's like a video with text on top of it and it looks really cool. Well, you can use like video.js for that, charts if you want to do really cool interactive charts, Grandom to make really neat looking gradients and interactive gradients, Parsley for form validation, so that means making sure that your forms do what they need to do and go where they need to go. Slick for carousels, okay, carousels are always a big deal. And 3 for 3D objects, just another way to kind of add some pizzazz to your website, or if you're making browser games. So you can really extend your JavaScript knowledge and really literally you could spend a lifetime learning all the nooks and crannies in the JavaScript world. But once you learn a lot of this stuff, you should be very comfortable with the basic front-end technologies. Okay? So now we need to go into the backend, the web server. So first, just from a high level, let's talk about what the backend is. So the backend always starts off, you need to have a programming language. Your web server could use any programming language, but that's going to be the language you use to tell the web server how to do the things. And it does that through a web framework. So every language at least has one web framework. Now what the web framework does, it basically sets up a template for how to do a lot of the things that a web server needs to do, such as routing. Routing means when a request comes in, what do I do with it? Okay, so someone goes to google.com/forms, what does it do? Parsing. Okay, oftentimes you can send data via your URL or via the request body. Your web server, your web framework is going to learn how to look in the URL and look in the request body to get certain information and parse it out so you can use it. So this way, whoever's sending the request can send you information like username and password or other pieces of information that you need to know. Session and auth. I want to talk about those together. So auth is authentication. So most websites are going to have users. So how do you verify who the user is in a secure way that doesn't compromise their password and information? Now, once they log in, it'd be really annoying if the user has to log in every time they go to the website. So oftentimes you'll create a session. It's going to be sort of like a cookie or persistent variable that basically one tells you that they're logged in and can also store other information you may use while they're logged in. So generally a web framework is going to handle a lot of these things and more. It'll also help you kind of interact with databases. Uh, you know, so depending on the framework you have, will tell you how much of this stuff it does. If it doesn't do any of these things, then you have to find another piece that does it, because you do need to do all these things. Because you're going to need to have a database, depending on your application. And you're going to need to have some way to connect your web framework, your web server, to that database to grab information, put in information. And once you grab that information, you may or may not decide to actually create the web page for the user on the server. So instead of sending the user the raw information, you're just sending them the already created website. That's referred to as templating. So you'll create a template that has like little sockets for the information, and then the server will sit there and say, here, I got the information, here's the sockets, let me mix them together, and then send that. The alternative is you send the template and the information separately, and this is kind of like what's going on with a single page application. Creating APIs. So what if someone did want to create a single page application? That means that's a clump of HTML, CSS, and JavaScript without the data. So they need a way to get the data from the server. So that's what an API often does. Okay, an application programming interface. It's basically a way for a program to talk to a server and say, hey, give me this specific types of information. Most APIs are what's called a RESTful API. What a RESTful API means is that you generally have certain endpoints. So that means you have certain URLs, and if you go to this URL, you'll have access to this information, or the ability to delete this information, or the ability to edit this information. But everything is done through different endpoints or URLs. So if I were to learn like Spotify's API, I would have to learn what different endpoints are to learn how to access the different types of information in Spotify's API to be able to use Spotify information on my website. Now, more recently, Facebook created a sort of a new way of doing an API called a GraphQL API. So instead of having multiple URLs, multiple endpoints, you'll have one endpoint that you'll send a query to. And you'll be able to access all the information through these GraphQL queries, which are like queries that instead of looking like SQL, which I'll mention later on, these queries look more like a kind of like a weird nested JSON object, which is gaining popularity in a big way in different applications. Now, whether you create a RESTful API or a GraphQL API, either way, it's interacting with your database. So you have your database that actually stores the information. The API is a layer that gives the rest of the world access to your database. And your database can kind of fall into two categories. A NoSQL database, which the main one is called Mongo. And what makes Mongo in most NoSQL databases fall in the same category, what's called a flat database, which means no information is connected. There's no inherent relationships in the data. It's just basically a flat document. Okay, so in that case, the benefit of that is it's easy to scale if you're going to be huge. So if you're going to be like the next Google or Microsoft, it's really easy to just set up another server to collect the same information. And since none of that information relates to the other server's information, because it's all just big globs of data, you can just set up more servers on a vertical level, while when you're using an SQL database, all that information could be, you can actually keep track of relationships. So I can sit there and say, hey, I have a table of users. Each of these users are connected to these things in the table of pictures. So a user has a lot of pictures, and you can keep track of these actual individual relationships, which can help you pull the information. But then all the information needs to be accessible to each other, so you can't really do that same sort of horizontal scaling where you just set up more servers. You just need to have a bigger server and more server capacity as your website grows. Okay, or you need to start breaking up your application into smaller databases of unrelated data. There's different ways of scaling. But most people, for most applications, oftentimes use SQL databases because they do want those relationships. So, and they all kind of use the same language for interacting or pulling the data, called SQL, structured query language. Well, Mongo's essentially going to store information more in a JavaScript way, like a JavaScript object, and has a totally different way of interacting with the database and working with the database. Mongo is pretty cool, in my opinion, in the sense that it's not hard to get up and running with Mongo. So if you're building your first couple applications, you can go get a Mongo Atlas account and incorporate Mongo into your application. Probably easier than any database. While using any of the SQL databases, you generally not only have to connect to the database, but you have to make sure you get what's called an object relationship mapper that helps you interact with the database. It can get a little tricky at first. Once you get used to it, it's not hard. But with Mongo Atlas, which is like a Mongo database service that allows you to just get a free Mongo database in the cloud, makes using Mongo pretty easy at first. There are several hosts and service providers for any of the SQL databases. Now, probably the first thing you should learn is Node.js when it comes to like backend frameworks. Because if you did the front end stuff, you've already learned JavaScript. So it just makes sense that you'd first stick around in JavaScript to learn the basics. Now you only need to learn at least one framework in Node. The ubiquitous sort of the one everybody knows is Express. But there's all these other frameworks. Oh, let me go. Let's go back. Okay, so Express, Koa, Happy, Adonis. There's all these other frameworks that are certainly worth learning. So you could spend, again, a lot of time just really focusing on JavaScript and specifically Node. And actually, let me tell you what Node is first. So JavaScript in the browser is a different world than Node. What Node is a program you can install on your server that allows you to run JavaScript on your server and create web servers from JavaScript. The one thing I think a lot of people don't appreciate at first is that it's a different world between the JavaScript that runs on your server versus the JavaScript that runs in the browser. So when you're creating your code, you have to really think about where's my JavaScript running to know which libraries you've brought in. Because oftentimes when you're talking about the browser JavaScript, you would do an include in your HTML file. You do like a little script tag that brings in a particular library. That'll be accessible to your browser JavaScript. While in your Node server-side JavaScript, you have to do like these requires. Like we require Express, require Koa. That's going to bring it in so you can use it on the server side. And there's two separate sort of like walled gardens. Okay, so it takes a little while to kind of think through that. So one of the benefits of having like another language that's not JavaScript is that you know, okay, if I'm using X language, that's backend, and when I'm using JavaScript, that's front end, and there's sort of a clear delineation, but then you have to learn two languages. Pros and cons. But you want to at least learn one of these frameworks. Probably Express is always a good starter. Some of these other, and then the thing is that when you take a look at a lot of these other ones, a lot of the more robust frameworks are oftentimes built on Express. So Express and Koa are two unique ones, both made by the same people. And then generally a lot of these other frameworks will take Express and start assembling a lot of the other pieces that you would need to have a full backend framework. Because Express is very minimalist, it has just the basics of what you need. So with these, you'll have like the object relationship mapper built in, session, authentication, all sorts of really cool stuff. In the Node world, there's several different templating engines. So these are just like, they're like little mini languages for you to create like template HTML files to mix your data with. So EJS, Pug, Handlebars, Mustache, Marco are in this bunch. Database interfaces. So again, if you're talking about an SQL database, you're going to use type ORM as sort of the main object relationship mapper in the Node world. Mongo is the package that's going to allow you to interact with a Mongo database. So you'll have to learn, you should probably learn both of these. But once you feel comfortable with JavaScript on the back and the front, you should go learn a few other languages. And at this point, learning another language will become really easy because the core concepts of any programming language, which are just basically your data types, your variables. So learning what types of variables they are, how do you create a variable, learning your operators, so like how do I add or subtract, how do I test if something's true or false, your control flow, meaning if statements, so how do I test, how do I control like this happens when it's true and this happens when it's false, how do I create loops, functions, how do I create little clumps of code, collections, arrays, and classes, sort of how do I do object-oriented programming. Those concepts are the same for all languages. The syntax, the way you do it is different. So once you've learned one language, learning another becomes a lot easier because you're not learning the concept again. You're just learning a different way of doing it. So I do recommend learning multiple languages, at least those basic concepts. One, it'll help you solidify those concepts, because the more different languages you do, you start realizing how much of it, you start realizing what parts are the syntax and what parts are the concept, and helps you sort of separate those two abstractions better once you've learned 2 or 3 languages. But every language generally has some sort of web framework for you to do all that stuff that I was just talking about. So if you're in the Python world and you go the Python route, you have Django, which is probably the most popular, and it's a batteries included. When I say batteries included, it means it has like all the stuff you need: authentication, session, templating, all that stuff. Flask is more minimalist, kind of like Express. Masonite's sort of a new hot framework on the scene. Now, C#, F#, and VB.NET are 3 languages, but they're all part of the Microsoft family of .NET languages. And they all can use the .NET Core library to do web applications. So you can literally make web applications with all 3 of these languages. Ruby. Ruby was super popular, and it still is pretty popular, because of a framework called Rails. But there are other frameworks that use Ruby, such as Sinatra and Padrino, and other uses for Ruby, but Rails is really sort of the reason people learn Ruby. Go. Go was a language created by developers over there at Google. It's a language created by people who developed in like C++ and Java for a very long time, who wanted to create something that kind of, they liked it better. So that gave you the power of C++ and Java, but in a syntax they thought was more usable. So that's Go. And their web framework is Buffalo. And Go is a pretty neat language. It has some pretty interesting ways of handling data. Java. Now, Java originally was a language created by Sun Microsystems, and the concept of it was that it'd be separated, because usually your languages would, like, one language would be supported like by Microsoft for Windows, one language would be supported by Apple for Macintoshes, and this meant like you had to wonder if any software or any program you wanted to buy was available on your particular operating system. So Java pioneered the idea of write once, run anywhere. So what you would do is you'd actually run the code in this thing called the Java Virtual Machine. And basically they designed their syntax to be kind of similar to C++, because they were trying to like get people who were C++ developers to switch over to Java. And then C# was Microsoft's response to Java. So that's why C# had a similar Java feel, because they were trying to steal all those people back via Java, because they didn't want people writing software everywhere. They wanted people writing software for Windows, so people would use Windows. So it's an interesting history of the languages, which is another reason why many of these languages have very similar syntax. It's not because everyone just thinks writing it in the same way just makes sense. It's because a lot of times, for marketing purposes, you don't want learning another language to be so different that people aren't going to want to learn it. Like, I'm going to give you a list of functional languages in a bit. Like those, the syntax is very different, and those are a little bit more work to learn. But from what I hear, there's benefits to learning it. Rust is a language created by Mozilla. They're famous for making Firefox, and this is supposed to be like, basically kind of serves the same role that Go does. It's like a low-level language, kind of like Java, C++, that is supposed to give you a new or better way of doing that level of work. But it does have web frameworks, Rocket and Iron. PHP is a bit of language that's been purely made for server-side web work. It's really evolved over the years. So you might hear people who use like PHP 10, 15 years ago, and they'll say really negative things about PHP. But because back in those days, PHP was still very young and underdeveloped. It didn't have a lot of security features that it does today. But now PHP is a really robust language with really awesome frameworks. Like the Laravel framework is really powerful, a really robust batteries included framework for building out web applications. I've been playing with that a lot lately. It's really cool. There's also like Symfony and CodeIgniter on PHP. Most of the internet is built on PHP, so like things like WordPress, which powers like a lot of the websites on the internet, is PHP. So there's a lot of value in learning PHP. Crystal's sort of a very, very new language. I don't know much about it, but it does have the frameworks Toro and Rails. Perl, even before PHP, Perl was what you use. So Perl's even older than PHP. And people kind of have forgotten about Perl over the years, but it still exists and it's still in development. Perl has evolved over the years. It hasn't quite made a comeback, but it's there. It's better than it used to be, and there is a framework for it called Dancer. Now, functional programming is a type of programming in which everything is functions. There is no object-oriented programming. There is no mutation. What does mutation mean? Mutation means changing. So I could have a variable called a that holds the value of 5 and then later change it to 6. That's mutation. In the functional world, all data is immutable. So if I create a variable called a that holds the value 5 and I want to make it 6, I don't make it 6. I have to make a new variable and do whatever to make it 6. So if I want to add 1 to it, I would say, hey, a plus b, new variable b, is going to equal the result of a plus 1. So, and the benefit of this is that it's easier to catch bugs. Because if you know that your function doesn't change the original data, it only creates new data, then you can compare the new data to the old data and ask yourself, okay, is this what I expected to happen? And if your function isn't doing what you expected it to happen, then you know that there's a problem and you go fix the problem. So that's sort of the big sort of argument for like functional web development. You can do functional development with any language that has also object-oriented features like JavaScript and Python, but some people prefer a functional web language like the ones I have listed on the screen because natively they have immutability built in, which means you don't not change data because you chose to not change data. The language is going to force you to not be able to change data and create those controls to prevent you from making those mistakes. So ClojureScript, which is a dialect of Clojure, which is a dialect of Lisp, which is built for web. Elixir, which is based on Erlang, which is built for web. Elm is another functional language, a little bit more unique, built for web. It's very popular for being known as there's no runtime errors. That's like their big thing. And then F#, which is part of the .NET family, was based on the Haskell programming language. Now we're going back to the front end. So for a long time, people would do the back end and they would do the templating in the back end. But that was a lot of, basically every time the user go from one page of the website to another page of the website, the template would have to be re-rendered, the data would have to be recollected, and these were large responses from the server, which meant that the server was using more bandwidth, which means it got slower as there was more requests. So over time, they came up with the idea of doing single page applications, saying, hey, how about we let the browser do all of it? We'll send the user this big application one time, and then that application knows when to ask the server for the information. So that way the server is only sending information as needed. So a bunch of smaller requests versus a bunch of medium-sized requests very regularly. This made the experience faster for the user, and it made the bandwidth that the server was using a lot less, making it cheaper to run the application, so everybody wins. And the frameworks that originally was Angular. I mean, originally it was Backbone even before that, but Angular was sort of the first really big one. And Angular had a very unique workflow. I'm talking about like Angular JS, Angular 1.7. And then what happened is that React came out with another sort of killer update to the idea, saying, okay, let's take this idea even further. Let's create what's called a virtual DOM, where we're going to have, now the DOM stands for the Document Object Model. So essentially what's happening is that your browser, when it receives like an HTML, CSS, and JavaScript file, it doesn't actually just run the file. It reads your file and then creates an object that represents what your code told it. So it's kind of like if you made a painting of me of the Mona Lisa, and then and then what I did is that I created a clone of the Mona Lisa based on your painting. Okay, now what happens to the clone doesn't change what happened to what's on your painting. So basically, once the browser has made a clone of your website, your files are left alone. Your files are done. So what you're manipulating is the clone of your photo, of your painting that is your code. And you're making changes to it. Problem is, we want to if you're doing a single page application, you're only rendering the DOM once when you initially load up the file. And we're looking for when do we need to make more changes to the DOM. So what React does, it creates a sort of a shadow DOM. It creates like another clone and changes that clone every time you make a change. It pays attention for changes on that virtual DOM and only makes the necessary changes to the actual DOM. So instead of re-rendering the whole website constantly, it's only re-rendering the parts that need to be changed, which makes for a faster experience. Don't worry if you didn't get all that. It doesn't make or break your ability to actually do the code. It's just so you can understand sort of why React exploded. So React exploded and Angular was like, okay, well, we're going to redo things to kind of fit these sort of more modern workflows. So then Angular 2 came out, which was like very different than Angular 1.7. It literally like broke everybody's websites. So everyone was really upset with Angular, and this allowed React to kind of build up some more market share. A lot of people switched from Angular to React and whatnot. Like Angular now is like an Angular 8, and it's really good actually. Like it's a really well done framework. And it's not that hard. At least it's not as hard as it used to be. But it did have an initial friction when they went from 1.7 to 2. So that's why you'll hear people say Angular JS, which refers to old Angular before Angular 2. And then when you hear Angular by itself, that's referring to 2 and above. Vue, which it's like Evan You is the person who created Vue. And I forget if he was ex-Google or ex-Facebook. So React was made by Facebook, Angular was made by Google, and then an ex-developer of one or the other, I forget which, I think it's Google, created Vue. And Vue really kind of incorporates some of the best ideas of both, and has become a really popular framework. I mean, at the end of the day, really what you're doing with all three of them in its current incarnation is you're creating what's called a web component. So you're splitting up your website into components. So you might, which are in separate files. So you might have a component for your navigation bar. You might have a file for your carousel. You might have a file for your footer. And you're separating the code. And in that separate code for your component, you'll do the styling, the HTML, CSS, and JavaScript. The difference is in Angular, for each component, you'll have 3 separate files. A CSS file, a JavaScript file, and an HTML file describing that component. In React, you'll have 2 files. A JavaScript file containing the HTML and JavaScript, because they use something called JSX, and a separate CSS file for each component. In Vue, you have 1 file for each component, because you'll have 1 file that has the HTML, CSS, and JavaScript for each component, which is actually going to be pretty much the way Svelte works. Okay? But that's really the big difference between the 3. Okay? And then more recently released, like in the last couple of years, you have Svelte and Stencil. And what these do is they're different. They're not a framework in the sense that there's all these libraries that are concurrently working to build your website. Instead, what you're doing is you build your application using Svelte or Stencil, a single page application, and then you compile it into web standard code. So that way you don't need to worry about all these extra libraries and whatnot. It just basically figures out, okay, what would be the normal JavaScript you need to make the site look the way you just designed it, and it'll compile it. And the benefit of this is that as web standards change, so let's say a few years now, a lot of the underlying what browsers can do changes. You don't need to redesign your whole website to meet the new standards, because React, Angular, and Vue will have to update their frameworks for the new standards. Svelte will just update its compiler. You'll use the same Svelte or Stencil code, and it'll just compile to the new standards. So it does kind of have these sort of long-term benefits. But they're still very new. They're not super adopted yet. But Stencil's workflow is a lot more like Angular. It uses TypeScript like Angular. TypeScript is a superset of JavaScript created by Microsoft. So they're very similar in the way they work. Svelte is very similar to Vue in the sense that everything is in one file. But Svelte even takes like Vue's sort of easy workflow and makes it even easier. Like when I tried out Svelte, I was actually really astonished by how simple it was. It's pretty cool. But literally the 3 big frameworks are where all the jobs are at, okay? Many big firms are using React, Angular, or Vue to power their websites. And then within any of these areas, you could literally spend your whole career just specializing in these areas, because there's such wide things that there's to learn. So in React, one of the things you need to learn is like state management. So what happens is that there are pieces of data called state. And when state changes, That's when the virtual DOM kind of re-renders or remakes that piece of the website. But what happens is it gets a little complicated passing all these variables around in your application, because oftentimes they're stored in your individual components. So you have to think, okay, well, this component's over here. It's going to send this data to this component over here. Who has it here? It gets complicated. So state management frameworks, what they do is they create sort of like a application-wide state. So basically a place where you can store your variables globally for your application. Redux is the one that's typically used with React. It doesn't have to be, but it typically is. Then there's all three of them have their own server-side rendering. So this is typically going to be some sort of framework that takes Express at its core and then builds in the ability to use React, Angular, Vue on the server side. So that way you can render your websites using that framework at the server level. And Next.js is the one for React. Gatsby, static sites are making a comeback for a variety of reasons. If you have a page that's already sort of has all the information all squished in, and it's rendered way before you make a request, then when the user makes a request, they don't have to wait for the website to be rendered. It'll have the whole user experience, and it'll just be faster to load, easier for search engines to search, and used for search engine optimization. So static sites are really kind of making a big comeback, and that's what Gatsby does. It allows you to have all that dynamic data, but the pages are rendered before and are rendered as static sites. So basically, you'll build out the pages ahead of time, but at the time of you build the website, you compile the website, it pulls all the information, and it uses GraphQL as the way to do that. So if you were thinking of learning GraphQL, learning Gatsby is a really good introduction to GraphQL, and it uses React to make the website. React Native is a framework for creating mobile apps using React. Okay, so you can, through your React knowledge, you can kind of stretch that out quite a bit and really specialize in React. Angular, state management, NGRX. Nest.js is a server-side version for Angular. NativeScript is another framework which you can use JavaScript to create mobile apps. So you could use Angular to create mobile apps using NativeScript. Vue, Vuex is the state management library for Vue. Nuxt.js is their server-side framework, and NativeScript is, you can also use Vue to create mobile apps. Content management systems. Now, these were sort of, they still are a thing, but they used to be much more of a thing. A content management system, the benefit of a content management system is that it creates a visual way of managing your data in the back end. So basically what you're doing is you're creating a back end, but then you're creating this visual layer on top of it. So that way people can add data visually and subtract data visually from an administration panel. So if you ever used WordPress, you know, you have like your place where you log in, you add your blog posts, and you can tinker around with the settings of your website, and you can pretty much edit your entire website without having to touch a piece of code. That's what a CMS does. It abstracts all that coding layer away from the person who's managing the website. And by far the most popular CMS or content management system is WordPress. And this is a really, especially if you're planning to go into like freelancing, this is a very useful tool in your tool belt, because using existing, you know, your medium to small business client, they don't have money for you to go develop a whole separate backend application, then design a single page application and do all this stuff. And if they're just making a website for like their restaurant, they probably don't need that. They maybe just need a basic WordPress website, so that way they can, you know, make pages with their menus and maybe a little blog about events at the restaurant. So being familiar with a couple different content management systems, so that way when that medium to small client wants a website, you can build it out very affordably using one of these, okay? Because then you can sit there and actually offer them your services at a price point they can afford, because this will take a lot of work off your table and still get them what they need. These are useful for that. So the open source ones are good because you can then get your own hosting and just install it on an individual host. Hosted ones, the ones that don't say open source, basically these are CMSs that are paired with the hosting, which means you have, like if I use Squarespace, I have to pay for Squarespace hosting service I can't use it without paying them. Okay, I can't take Squarespace's like CMS code and then install it on my own server and have my own instance of Squarespace. Like WordPress, I could download the WordPress code for free, install it on my own server, and now I have WordPress. No cost. But And that's not the case for the hosted ones, but some of them are really popular. Squarespace is very popular. Wix is very popular. Webflows is like new one that has supposed to be really flexible. Mezzanine CMS is one that was created with Python. That can be nice. But that's like that was like a business model for a lot of companies. They'd create their own SMS or CMS, and basically their business model was, hey, if you like our CMS, you have to pay us for the hosting, like Squarespace, and then that was their business. And you still have new companies coming out like Webflow that kind of are in the same space. But nowadays, a lot of things are moving to headless CMSs. The difference with the headless CMS is that when you think of WordPress, WordPress not only like manages your data and allows you to create like a new blog post, but it also managed your website, actually managed the visual. So you'd have like WordPress themes, and that's usually what you would hire people for, to create like WordPress themes for you, to get your basic WordPress site up and running. But headless CMSs just manage the data. That's it. And then they deliver it through an API. So in that case, you could create a React Angular Vue application and get the data from your CMS via these headless CMSs. So this, and the benefit of this is, if you're really good at doing those front-end React Vue applications, and you don't really want to be doing back-end applications all the time, but you want to do robust applications for your customers, you can then use a headless CMS. Create your data models in a visual way, set it all up, and then just basically do your front-end application. You don't have to worry about building up the back-end from scratch. And that's what these do. Contentful I've used is pretty cool. I haven't used Butter CMS yet, or Agility or Content. WordPress actually has a REST API built into it, so you could use it as a headless CMS. Graph CMS is a headless CMS that uses GraphQL, if you wanted to spend more time with GraphQL. DevOps and quality assurance. So this is more like operation type stuff. So basically, it's no longer you're building the website, it's more making sure that the website can be deployed. So being able to set up like virtual private servers on services like Google, Amazon, Linode, DigitalOcean. Being able to work with containers, and containers are generally created through a program called Docker. Okay, so again, containers are created through a program called Docker, which what it does, it creates basically, imagine if you could take your program and put it in its own little like box, so that way all the software it needs is only in that box, all its dependencies are just in that box, so that way I can have lots of websites on my server, each of them in their own little box, I don't have to worry about the dependencies of this program screwing with the dependencies of this program or this website or this web application, because they're all in their own little containers that I can quickly just plop wherever I need to plop them. So in that case, you can easily move your website from one server to another because it's all through you just slap the container on the computer. Cloud functions. This is a little bit harder to explain. This is the easiest way to think about it is you're taking your application, instead of having it persistently running on a server that's always on, it's done as a function, and certain things will trigger it, like maybe visiting a particular URL, but your code gets triggered by something and runs as needed. Okay, which means you save a lot of money because you're not paying for constant server uptime. This might be good for like a convention website where eventually people are going to stop visiting it, so eventually the function will stop running, so you don't have to pay any more money. But the serverless framework was a framework created for working with such types of situations. So the serverless framework is a good way to learn to get your introduction to working with sort of cloud services like Amazon's Web Services, Google Cloud, Microsoft Azure, learning to work with these things. Now, end-to-end testing, basically what you want to do, especially if you're working in large development teams, is you want to learn how to do testing, which means setting up something like Jest that'll create tests in your program, so that way as people create additions to the program, what you can do is you can run the test, and it'll make sure that everything still does, given the certain information, that it returns the information back that it's supposed to run. So if someone else changes a small piece of the code, you can run the test and notice if something broke and where it broke. So learning how to create tests is a very valuable thing that's done by DevOps and QA people. DevOps are generally more senior people in this space. Basically they're the ones creating the tests and designing the whole. Okay, here are the Docker containers are going to look like. This is how the server's set up. This is these are where the tests are set up and how we're going to deliver those tests. That's what the DevOps person does. The quality assurance person is oftentimes the person executing those tests. So they didn't build the test, but they make sure that the test happens. So they're, okay, we're going to test the software, make sure it works. Okay, let's test the next thing, and oftentimes a lot of developers will find sort of their first development job as a QA engineer, running those tests, and then they're able to kind of move up into other areas. Circle CI is a platform for doing end-to-end testing. That's also a useful thing to learn. Now, what if you want to develop mobile applications? So we're almost at the end of this presentation. If you're talking about iOS, the original language to do iOS applications in was Objective-C. But that was a really robust language, probably overkill for what's needed to make a mobile application. So eventually they created what's called Swift, which is much easier. And then Xcode is a software that you use to make those applications on a Mac computer. On the Android world, you originally used Java to create Android applications. But again, same reason, Objective-C was like overkill, Java was overkill. So Kotlin, which is a much easier language to learn and easier to use, became sort of the main language for designing Android apps. But the problem is, if you're doing Swift, you're really only doing iOS applications. If you're doing Kotlin, you're only doing Android applications. And that's fine. And there are benefits to doing that because it gives you access to all the latest features of the phone. So basically any kind of feature that's added to an Apple device, Swift is going to give you access to those latest features. But most mobile applications don't use the latest features. Most mobile applications are very basic, and your customer needs them for both Android and iOS. So one way you can do it, where you can have it for both, is you use kind of one of these other tools. So with Python, there's a library called Kivy that will allow you to create iOS and Android applications. In JavaScript, there's React Native and NativeScript, which allows you to make applications for both iOS and Android. Now C#, F#, VB.NET, the whole .NET thing, they have a library called Xamarin that allows you to make code for iOS and Android applications. Ruby has something called Ruby Motion. I'm not sure how popular it is, but it's there. That allows you to do mobile code for both. And then Dart has a compiler called Flutter. I think Flutter was made by Google, and Flutter allows you to take Dart code and compile it into iOS or Android code, so you can make applications for both. This is becoming like a much quickly growing popular thing to do. So Dart's growing very quickly because of Flutter. So that's another language you may want to learn. And that's the end of the presentation. So hopefully you guys learned a few things out of this. Now there's a lot to learn there. Again, there was more stuff covered in this presentation that you could probably spend a lifetime to learn. But this will give you an idea, like, okay, where do I want to specialize? You got to learn the front end piece, the HTML, CSS, and JavaScript. You should at least learn 1 or 2 languages and 1 or 2 backend web frameworks. But then after that, you could specialize in the DevOps side. You could specialize in mobile development. You could specialize in a particular front-end framework. You could just specialize in React or specialize in Angular, specialize in Vue. There's a lot of room for where you'd want to specialize in and grow your career. So hopefully this gave you a good guide. I'll see you guys next year. We'll do this again. Have a great day and enjoy.